Hello and welcome to the Bravas Podcast. This time we're going to talk about networking, home networking, and things you need to know there. So Keith, I think probably one of the things we've all explored during these difficult times is how much our networking has changed. Have you been struggling at home with that?
Well, not struggling because we have a pretty great network, but yes, we've definitely been relying on it pretty heavily the last couple of weeks.
Okay, well let me bring in today's guest, who is Bryce Nordstrand. Did I say that right, Bryce?
Yeah, absolutely. Most people don't, so good job.
Well, I'm particularly good at butchering names. Bryce is the Chief Sales Officer of Access Networks. So, Bryce, why don't you tell us, maybe start with a bit of your background and how you got where you are?
Okay. Probably going back 10, 15 years, I was an integrator, so doing integration work, home theaters mostly at that time, and then as the market progressed into automation and those kind of things, we got heavily involved in that. And I started with Access Networks about 6.5 years ago now. Came in as just a straight up salesperson and have migrated up into the chief sales officer position and run the sales and marketing side of the company. So.
Great. Access Networks is pretty well known to the systems integrator community, but can you talk a bit more about it, maybe from an end user point of view, and how you and where you guys focus?
Sure. So, we started probably about 10 years ago, mainly doing custom program configured networks for high-end residential applications. So Cisco, mostly at that time, was what the product we used. And we've slowly migrated into a Ruckus product. And then more recently, we actually have our own brand of product, which is Access Networks product powered by Ruckus. The big difference is how we support it, the things that come with it, how it's specifically tailored to residential application. It's very difficult to take enterprise product and put it into a residence and make it work properly. A lot of people think it's a very simple process, but it's not. So that's probably the biggest thing that we do is we take enterprise level, high quality product and we make it work in the residential application.
Okay, so we talked a bit about the pandemic earlier, Keith and I did. What have you guys seen? What's the difference you think people are thinking about their networks since we've all been spending so much time at home?
Yeah, so the biggest difference is probably how I want to find the right word there, how people just don't really seem to be concerned about price so much as performance. It was almost like the other way with the home network where they wanted performance, but there was always this price thing about how do I justify that kind of money being used or being spent on a network in my home, from a small home to a very large home. And the biggest difference that we've seen now is performance it's like buying a Ferrari or buying something like that. It's all about performance right now, and the price is almost secondary to that. As long as they have what they need, working from home, kids from home, getting schooled from home, the amount of traffic and pressure that's been put on the home network in the recent 3 or 4 months has been good for Access Networks, but it's what it has done is it's exposed a lot of problems that people had in their home network that just kind of overlooked when they weren't working from home and the kids weren't being schooled from home, because it was more of just a convenience thing. It wasn't a necessity, and now it's really just this huge necessity that they have to have working all the time. So
when you say performance, talking about a network, what should someone expect to see as far as a performance increase? And I guess when would someone know they have a problem?
So you're always at the limitation of whatever your ISP is. So if your ISP speed is, if you're buying 100 meg.
Your ISP is your internet service provider?
Internet service provider, correct. So if your bill says that you're paying for 100 megabits per second down, and you're doing speed tests on your Wi-Fi and you're getting 100 megabits per second down, then you're getting the maximum of your performance as far as getting to the internet. If you're trying to move big files around your house, if you work from home and you're a videographer or something like that, and you have a server or a hard drive that you're trying to move something from your computer to that server, then we can talk about other things in regards to speed and internal in the house. But there's a lot of people buying gigabit speed now for their home. And reality is that most of the devices that we hold in our hand and that we work on are limited to a much lower speed than that just by the nature of Wi-Fi. I actually just finished a white paper on this that we're going to be sharing with our dealer partners that talks about what the reality is that. And the reality is it's really about 30 to 40% of what your gigabit speed would be on a iPhone or an iPad would be about 30 to 40% of that. Maybe a higher end computer would get 50 to 60% of that, but it's not. We get all the time. We get people saying, "I pay for gigabit. I should get gigabit on my Wi-Fi." And the reality is that the math and the physics and interference and all those things that doesn't happen. A lot of the marketing out there is playing with numbers. It's saying that my amplifier do 10,000 watts, but you only have 120 volts at the wall coming into it. It's that the math doesn't add up. So,
can you talk a bit about the different standards and compared to that as well? Because I know for those of us who've been using Wi-Fi for a long time, we've been through A, C, and N, and then some combination of letters. What do those letters fundamentally mean to somebody who's trying to maximize the amount of wireless to those modern devices?
Yeah. This is one of those things that it's very confusing even for a lot of the people that we deal directly with, not just the end users. And there is N and AC, and then there's AX. AX is the latest standard that was released, and it's actually they're changing the monikers to Wi-Fi 5, Wi-Fi 6. So N is Wi-Fi 4, AC is Wi-Fi 5, and AX is Wi-Fi 6, and they're just trying to make it more consumable for end users, which is good because when you walk into a house and you start talking about 802.11 AC, AX, and homeowners just and a lot of people just kind of glaze over, like, I don't know what all of those letters and numbers mean, and they shouldn't. It's not their responsibility to know those things. But Wi-Fi 5 and Wi-Fi 6 is much more easily understood, and the big difference between them is when they create a new standard, what they're really trying to do is create more points. Think about it as points on a graph, where you have each individual point is a data point, and it transmits that data point at the same time as all the other data points. And what Wi-Fi 5 did, or 802.11 AC, is you had 256 points on that graph that allowed to transmit 256 points of data at one time. So you would take some information, you'd break it down into 256 pieces, and you'd send it at one time, and then it would receive it one time. Now, there's a bunch of other things that go into that as far as error correction and things like that. What Wi-Fi 6 did is it takes it from 256 to 1,024. So you've quadrupled the ability of individual data points at one point in time to be transmitted. What this means is a great amount of speed increase. The problem with that technology is its close proximity. So you have to be very close to the access point for it to actually use the 1024 points on that graph. And the further you move away, the further and further those points have to get apart. So the less and less points you have. So you go down to 256, you go down to 54. It's all divisible in quadrants, right? So, and when you get away, what happens is those points have to get further apart because of interference. So if the points are tightly put together, what happens is the interference is high, and then you have too much error correction. So the mathematics in the devices, the equipment, they automatically start making these adjustments. And that's why you'll see, if you're not in close proximity to an access point in your house or a Wi-Fi device in your house that's transmitting to your device, and if you're far away, you'll see, do a speed test, and you'll see like 30 meg down. And that's because it's done all the math and said, well, you were too far away for us to send those points all tightly knit together, because interference is just going to break them all up anyway. So I mean, there's a lot more to it, but that's the basics.
Yeah, no, I get that. So that says to me that if I'm going to go for Wi-Fi 6, it's a bit like the conversation we're having with G5 for our phones. It's going to be very fast. We're going to have to be near a transmitter. So in a big house, if I'm going to do Wi-Fi 6, does that mean I also need to think about my wired network and where I put through, physical connection, those access points that allow my devices to get into the network, if that makes sense?
Yeah, absolutely. I mean, the problem that we face in residential application is for years and years and years we were marketed to by the big companies out there that said, you buy this router and it covers your whole house. where there's no qualifier there. What's the whole house? Is the whole house my house, which is around 3,000 square feet, or is the whole house 10,000 square feet? Because they didn't it covers your whole house, which is 2,000 square feet. So because of that, there was a misconception that we didn't have to put in multiple access points. And even when we did, people started saying, well, why do I need 5 of them? Well, your house is 10,000 square feet. You need at least 5 of them, based on the math of it. And so that's what it comes down to now with the new, with the newer Wi-Fi and Wi-Fi 6 specifically. We're seeing a reduction in how far the transmit distance is with the greater throughput. So if you really want that really high throughput and you want to get that gigabit speed, depending on the devices that are coming out, then you've got to have more access points and have them work together as a system. So we're really seeing that number come down to 1 access point per about 1,250 square feet with Wi-Fi 6 to be covering properly, which is very different than it was with N. N was 2.4, and you had 1 access point per 2,000 to 3,000 square feet, and most of the time you were good. So it's a very different reality now.
So Bryce, when you talk about covering a whole house, what are some of the practical things within the home that would keep an access point besides just distance? What are some things we should look for to make sure we're actually able to adequately cover a space?
All access points are designed to be mounted from the ceiling pointing down. So if you mount them on a wall or under a bed or in a cabinet or in a refrigerator, which obviously you would never do that, but if you were to do something like that, it's not going to perform the way it was designed. They're designed to be mounted to the ceiling like a smoke detector, dome down, and that's very important. The other thing is as many of them, we have the capability of doing what they call mesh now. So you have some of your access points are wired. If you have a hole in coverage, you add a wireless access point in, the one that meshes into the system that just needs power. We try not to do that. So back to Nigel's original question is what should we be doing in a home is try to get wired to every location. Now in a retrofit application, you could absolutely make the argument that I can't get wired to that location because it's a brick wall or whatever, the aesthetics don't allow it. So at that point you would have a mesh access point, but you still have to have roughly a 2-to-1 ratio, meaning 2 access points that are wired to 1 that's mesh. And then as the numbers increase, you would have 6 and 3 or 9 and 5 or something like that, depending on how large the home is in a retrofit application. But the wired portion of the network is still incredibly important when it comes to supporting the Wi-Fi solutions.
So you talked a little bit about mesh networking and just that wireless capability. One question I always get from clients is, can I just buy a wireless repeater? Tell me how wireless repeater and mesh network aren't the same thing.
Okay. So a wireless repeater actually is a client. What a mesh network does is a mesh network says, I'm going to connect these 2 points and I'm going to use a dedicated radio to connect those 2 points. So what happens is that radio and that radio on each end say to each other and to the system, I am no longer being used for anything else than this connection. What that means is that it's 100% of the time, right? It's always working as a connection. It's almost like a point-to-point bridge. It's like if I had to send data across the city and I had 1 antenna here and 1 antenna there and they were dedicated for that, all I would be doing is setting data between those 2 places. It's the same concept in a mesh, is these radios have made this agreement that that's how they're going to connect. In a repeater environment, what happens is the radio that you're using is broadcasting and all of the other devices are talking to it at the same time on the same Wi-Fi band. And the way Wi-Fi currently works outside of Wi-Fi 6, and you won't see repeater systems in Wi-Fi 6 because of this technology, but what the devices are currently doing is the Wi-Fi, when one device talks, everybody else listens. That's how the standard is written. So if you think about it as we're all in a room together and I'm talking and somebody else tries to talk, I have to stop talking. And in a repeater environment, what's happening is the repeater is now the one talking to the one that's trying to send out Wi-Fi to everybody else. So as soon as that repeater starts saying, I need to talk to you, everybody else can't do anything. So you're limiting the ability of all the other devices at that point. In a mesh environment, because those radios have a 1-to-1 connection, you're really saying okay, this one can still work as an access point and talk to additional Wi-Fi device. So you're effectively doubling your capability, because now you have two Wi-Fi radios that are talking to two devices rather than one trying to talk to one. Well, nobody else can talk. So does that make kind of sense of why they're not a good idea?
Yeah, so it sounds like mesh behaves like a wired access point. It's just doing it wirelessly.
Right. Yeah, exactly. Yep.
Okay.
Yeah.
I want to ask a sort of more stupid, I live in an apartment question. Most of us that live in apartments, which maybe are 2,000 square foot and less, find that our networking stuff all sits in a closet of a spare bedroom, which may be at the end of the apartment, and the first thought is to put your wireless access point in there, and it's just got so many walls to get through. Is there any way for people who live in, a space that should be covered by one access point to actually get more access point access, or how the best way is to say it?
Right. Yeah. So in an environment where you don't have control over the infrastructure, meaning the wires that are in place, mesh would be the way to do that. Mesh would be the solution to get a good connection between a closet on one end, and for some reason it's always on one end. It's never in the middle, right? That closet is always on one extreme of the home. And use a mesh. That would be the way to do it. Just to give you an example, I have in my house, I have pool equipment outside, and I wanted that pool equipment connected to my network, but it was a tract home, and I didn't have control over whether they ran a wire there when they built the home. So I actually put a mesh access point out by my pool equipment, specifically for the reason to connect my pool equipment via wire through that mesh access point back into the rest of my system. So now I have this, ability to control my pool equipment through a mesh access point. And as far as I'm concerned, when I'm on my phone or remote or wherever, I can turn on my spa, whatever I want to do. It doesn't appear as anything other than a network connection to me. So, and the nice thing about it is that I ended up actually repeating out into a shop building that I have in the backyard for working on, various projects. So it was like a double whammy fix. It was the ability to do this. So the same thing would apply in a house or an apartment that only has one network location and it's on an extreme. You would put a mesh access point. Well, let's say that access point was near where you had a printer. Well, printers work way better when they're hardwired. So you could hardwire that printer into that mesh access point, and now you have this printer that's no longer a wireless client. It's connected wired, even through a mesh access point. So there's a lot of advantages to using mesh.
But that does mean I have to put a mesh-capable router in as well. So, I mean, that probably means for most people a complete change of the network to make that work, I'm guessing.
Yeah, well, so we always try and have everything, in the audio world you call separates. You have a separate amplifier and separate speakers. In the network world, we do the same thing. We're not a big proponent of all-in-one systems. So router with wireless built into it, we would advise against that. Go with router and then wireless as a separate component in that system as an access point, a Wi-Fi access point. And the reason why is because you're going to get higher performance just by the sheer nature of the fact that there's two separate processors doing two different jobs.
So we are getting a lot of questions from clients about mesh systems because that's what's being marketed right now. Is all mesh made the same?
No, there is some fundamental differences between the two. But remember that mesh is not designed to be a performance-driven solution, meaning you're not going to get the highest throughput, you're not going to get the best performance with mesh. Mesh is designed to be a coverage solution, and that's and really the Wi-Fi standard is designed to be coverage. It's not really designed to guarantee any level of throughput. That's why the mathematics play into what your speed test will actually look like, and why we advise against doing speed tests, because it's not, even if you're doing 300 meg down on an iPhone, there's nothing on that iPhone that will ever use 300 meg down. Like, it just won't. It's a 4K stream is 25 megabits per second. So, in the world of mesh, it's a coverage solution. It's not a performance solution. And so depending on which system you use, you may see a little bit better performance, but they're all going to have their weaknesses. And it's all based on interference and placement and a lot of different things that go into play when you're setting those systems up.
Sure. You mentioned speed test. Is there a practical limit to how much speed people need, or how much benefit are people getting from the overhead of going up to gigabit speed?
So they're going to get benefit in the home. If there's multiple clients and a lot of things happening at one time, they're going to get some benefits there. But they're not going to necessarily get it per device if they're using iPhones, iPads. Now, if they have like a Dell XPS laptop that's in our world 3x3, which means it has 3 transmit and 3 receive radios, we're getting deep into the technical side of things. But if it's something like that, then yeah, they would want to make sure that they have an access point that matches those specifications, and that's the kind of things that we talk about with the Bravas team, right? Like how do you qualify what devices you'd use and what access point you would need for that device to perform at its highest level. And again, if they were moving large files wirelessly in the house, meaning from the device, they created a whole 4K or 8K video on their laptop, and they want to put it on a server, or they want to get it up to the cloud. That throughput will help with how fast that file moves. Will it make it not move? No, it could move over a 1 megabit connection. It's just going to tell you you're going to get the spinning wheel of death or something like that. So, but there are a lot of advantages in making sure that the performance of your access point matches the performance of the devices in the home. So that way you're maximizing.
One of the things that Bravas has done is work with Access Network to make this easier for customers, homeowners, even people designing and building homes to get the right network. Can you talk a bit about what we've done together to really try and simplify that?
Sure. Yeah. So I sat down with a bunch of the people sat down virtually with a bunch of the people from Bravas, and we came up with some solutions using a couple of different manufacturers, partners that you guys have, to really give some scale. And whether it be a very small home, 1,500 square foot condo, all the way up to a 40,000 square foot home, we have a kind of roadmap that is not all of the answers, but it at least gives you starting points. And those starting points are there so that when you're talking about a project and the size and scope of that project, that at least you have some idea of what the budget number should be. The thing that we always talk about, and we train this into our partners, and we know that it's used readily with homeowners, is 8 to 12% of their AV project should be in the network. And you start throwing around big project numbers, and that's a big number. But the reality is when you have a big project, you have a lot of connected devices. And a lot of times the homeowner isn't even aware of how many devices are actually going to be connected to their network, because a lot of it's invisible to them. You're putting in shade controllers, lighting controllers. If you do some of these new lighting panels, every 8 or 6 loads in the house is a separate IP connection to control, to be able to control those from a phone or an iPad or from a keypad on the wall or a touchscreen. And so you start adding all of these things up, and as the project size increases, the curve follows for the network. It just goes right along with it, along with things like power conditioning. If you're doing equipment racks, wiring, labor, all those things scale right with their foundational items, and they're ultra necessary in order to have a successful product. So what we've tried to do is really give Bravas, the team at Bravas, those starting points within that scale to kind of know where, okay, so if I have a 9,000 square foot home, these are my 3 options to start with, and then I need to see where my AV project and my automation project sits, and then I can kind of figure out which direction I need to go up or down.
Brilliant. Well, I think networking is probably one of the subjects we're going to come back to time and time again. But before we wrap up, we like to play, I don't know what we call it a game, whether it's a game or not is another question, the 3-question game, where we always ask the guests the same 3 questions just to see how they use technology. So, Bryce, the first question is, what is the one piece of home automation technology you think you couldn't live without? So, I'm a simple guy, even though I've been in the industry for a long time. And to me, it's some type of universal remote. Without that, I feel, I don't know if you can tell, but I got a lot of sun. Just recently, I was away for 5 days and my wife was home, and our universal remote, which is a brand that you guys sell, so wasn't working.
and it's more than a universal remote. It does some lighting control and things like that. And I'm out in the middle of California high Sierras where there's no real cell connection, and I'm getting, hey, this isn't working. And so then I have, when I had cell service, I'm contacting people at my office to see if they can check the network to make sure that there's no, and we didn't find anything. So it was probably just a glitch, and glitches happen. But that kind of thing, where now you've got to hunt down the Apple TV remote, you got to hunt down the Sony TV remote, and it's just annoying. Like, that thing should just work all the time. And when it doesn't, it's super frustrating. So
is there one job question too that you've done that you go, wow, is there a home you want? So what's the best sort of implementation you've ever seen? Can you think of one?
When you sent me this question, I was struggling with this because one of the things about what we do, personally, I've done some interesting stuff with my integration company back in the day, but it's been years since I've done anything real heavy lift with that stuff. And we really don't go out to a lot of projects because of we're an infrastructure product, so we don't really get to see. We're not the theater guys. We don't get to go out and measure screens and listen to the audio and do all the cool stuff, So, the thing that I've seen probably the most relevant recently is public Wi-Fi. That's becoming a really big push across our industry. For even like very small entities, like small cities, small public areas within cities. So, and the reason why is they want to cater to somebody being outside and somebody being in the community, public parks and things like that. And so I think that kind of stuff is cool because it draws people back out of their home, which is obviously right now is one of the things that people have been spending a lot of time in their home. So trying to get them back out into the public, but maintain, safe distances and things like that in parks. If you have Wi-Fi there, you can feel like you're still connected. A lot of people, in the small areas, they don't have the best cellular coverage, or maybe their kids are with them and they're trying to go have a picnic and they want to bring the iPad so their kids can watch a little movie while they're having a picnic. There's a lot of things you can do with Wi-Fi. So that's kind of the thing that I really think has been a lot of fun to get involved in. Okay,
last question. If there was one magical gadget you could wave a magic wand and get, do you have a sense of what that would be?
It's not really a gadget. It's more of I think this is something that our industry as a whole has struggled with, and I know partners like Bravas have excelled in, which is a unified operating system. Something that really ties everything in your home into one system that's easy to use. There's so many solutions out there, and I think if somebody could wave a magic wand and say, this is the end-all be-all that connects all of these devices, because what happens is, we have our mindset as an industry, and we're going to put in, Control4, Savant, Crestron, whatever the system is, and we put that in, and then the homeowner goes and buys a device. And they say, okay, I put this thing in, and how do I control it with my Control4 app? Well, you can't. It doesn't interface. And they're like, well, I thought this thing was supposed to, So then there's this whole awkward conversation about, what did you sell me? And I think that's the biggest problem right now is there's so many different standards and so many different people that are trying to own the market. And if we could just get past that and wave a magic wand and say, make it all play together and have one thing that works, I think that would be incredibly powerful. And, whether we ever get there or not, I think that's why it's a dream, right, Nigel?
Exactly. Well, no,
we may never get there.
It's like the conversation about universal remote controls, and I think this is maybe a conversation we need to come back to, as I'm guessing will be networking, because I'm sure we will have lots of follow-on questions and things to discuss. So, Bryce, thank you. That was great. Thank you for joining us on this podcast. So from me and Keith, we'll catch everybody next time.
Thank you.
Thank you.